Okay, guys, so this week you're going to be learning about absolute minimums and maximums and how to find them. And so what I thought I'd do is walk you through some of the algebra with some of these problems that's required. So we're going to be kind of focusing on how to work the algebra. I have a warm up there, so we'll go ahead and work it. If you want to pause the video, you can. But with this, find the derivatives. So I'm going to do 15 times 7 halves. I'm going to use my calculator. And I get 52.5. I don't really care. 52.5 x to the 5 halves, because if I lower that by 1, you're going to get 5 halves. And 7 times 9 halves is 31.5. X to the lower it by 1, 9 halves minus 2 halves is 7 halves. All right, so to find the critical values, right, you set it equal to 0. It's not going to be undefined anywhere. We just got to figure out where it equals 0. To do that, you want to factor out, remember a while ago we talked about this, the most negative fractional power, so that would be x to the 5 halves. So I'm going to factor out x to the 5 halves. And I'm left with 52.5 here. Now, 7 halves divided by x to the 5 halves, when you subtract it, you get x to the 2 halves, or x to the 1. So it's minus 31.5x. Set that equal to 0. Now, x to the 5 halves, that's going to be 0 at 0, because 0 to anything is 0. So x equals 0 there. And if I set this equal to 0, I get 52.5 equals 31.5x. And divide by 31.5. And I'm going to use my calculator. So 52.5 divided by 31.5, and I get 1.666. I'm going to hit that as a fraction. It's 5/3. All right, so we've got two critical values. Don't forget about 0, and we got another one at 5/3. Okay, so remember the critical value is where the derivative equals 0 or where it's undefined. Okay, I'm going to clear this off, and I'm going to change the way that I'm writing on this, so it's a little more permanent. Hopefully you had a good Easter, and not too much time left. Make sure that you're uploading your assignments. There will be a class assignment this week and one Pearson. So just kind of keep in mind some things when they're talking about relative and absolute extrema, it's important to keep in mind the difference between them. So, when you're given a graph, let's say over some interval of x, let's just go from A to B. The absolute, this here point right here is a relative max. This is the absolute max. You have to keep in mind that I'm going to go down here. An absolute max is the absolute highest point on the graph over an interval of an x. So the highest point would be this point here. It could be the end point at B. And relative max is the highest point relative to everything around it. It's a peak. And the way that I think about it, it's Mount Aggie is a relative max and Mount Everest is an absolute max. So the highest of the high is the absolute. A spot can only be one or the other. They can't be both. Just mention that. An absolute minimum, so like here would be the lowest point, so that would be the absolute minimum, and a relative minimum would be here. Okay, so just keep in mind that it's one or the other, not both. And some things to keep in mind: relative extrema, they don't occur at the endpoint. So like we didn't worry about that in the last section. We're worrying about them now because we're talking about absolute extrema. Absolute extrema, it can occur. I could have a graph, let's say that went up and went down. It can happen, not an endpoint, but it can happen at what you consider relative max, or I don't want to call it that, but it can happen in between the endpoints. But a relative minimum can't be. Okay, but okay. Extreme is classified as either relative or absolute, not both. That's the point I'm trying to make. It's one or the other, it's not both. So that the absolute maximum, is the highest point and the absolute minimum is the lowest point. Okay. So here we go. Here's a nice graph. All right, so locate all extrema and classify them as relative, extreme, or absolute. So I'm going from -4. So I'm only considering, I'm not considering all of this graph, from -4 to 7. Okay. So with considering the endpoint, I have to look at the endpoint. So there's a point here, and let's see, there's a point about right here that it crosses. There's a maximum here. That's not, this is a minimum for sure. There might be a minimum here, hard to tell. It doesn't really look like it. We're going to assume it's not. So those are my points that are, you know, points I need to check. They're critical values, so to speak, and the endpoints. So when I look at this, the highest point on the graph occurs at x equals 7. So 760 would be my absolute max. And the lowest point on this graph between 4 and 7 occurs right here. So that, we'll call it 4, negative, going down by 5. So I'd say -4. So 4, -4, it's an estimate. That's the absolute minimum. All right, and then this point here is a relative max. So 1, 2, -3, about 22 maybe, kind of making a guess, right? That point is a relative max. Okay, it's a relative max. This point's nothing. It's not an absolute maximum or minimum, so it's nothing. Okay. All right. So you don't use endpoints for relative extremas. All right. So there's a theorem that they're going to talk about, is the extreme value theorem. It says if f of x is continuous, i.e. no breaks, no jumps, no asymptotes, no holes, on some intervals of x, it'll have both. It has to have, no option. It has to have an absolute minimum and an absolute maximum if it's continuous. All right, so there's not an option not to have one. Note the minimum or the maximum can happen at the endpoints. Yeah. Okay, so how do we locate absolute extrema? It's a little different than relative, but not much. You make a table. You include the two endpoints that you're interested in of x, and then you find all critical values of f where the derivative is 0 undefined, in other words. And we only want the critical values between a and b, because if it doesn't fall within the range of x that we're talking about, we're not interested in it. Okay, so we find all critical values between a and b. We put them on the table like we do. We're doing our sign test now. And we're going to put all the places where the derivative is 0 or undefined and the endpoints on the table. And I'm going to, oh, sorry, I'm not going to put it in not doing a sign test. I don't need to do a sign test. Sorry. Critical values, we're going to make a table like so. And, you know, we're going to put our endpoints on there, and we're going to evaluate the function at these various points. And any critical values that lie between a and b, I'll just call them xc's, you know, we're going to evaluate. And then what happens is okay, so let me read it. So I put it in the interval, I evaluate f of x, not the derivative, but f of x for these values, f of a and f of b. And I'll make a table. And then all I have to do, the maximum is the highest value of f of x and the minimum is the lowest. So whatever those come out to be, then that'll tell me what they are. Okay, so just to do a quick example of something like that, the absolute maximums and minimums on the interval, and state where these values occur. Okay, so to find this, I'm going to go ahead and take the derivative. So the derivative of this would be 6x minus 24. Is that right? Yeah. And I'm going to set the derivative equal to 0. All right, so if I solve for x, you could work that through. You're going to get x is 4, and that is on my interval of x. It's telling me that x is between -1 and 5. So I'm going to make myself a little table, and I'm going to put the endpoints on there, -1, 5, and 4 was in between. So those are the values I'm going to test for the absolute extrema. So what you're going to do now, real simple, you're going to plug it back into f of x, all right, not the derivative. All right, so f of -1, I'm just going to use my calculator. It's 3 plus 24 minus 1. All right, for that I get 26. F of 4 is 3 times 16 minus, whoops, 24 times 4 minus 1 is -49, way down there. And f of 5, I'm going to plug 5 in there. 3 times 25 minus 24 times 5 minus 1, and I get -46. All right, so this is the only candidates I have. So the highest one is the maximum. So the maximum value is 26, and it occurs when x is -1 on that interval. And the minimum value is -49, which occurs at x equals 4. So this is the absolute max, and that's the absolute min on the interval. Okay, that's it. So we'll do another one just to make sure everything's good. So I'm going to take a derivative there. I get 3/3 times, it's 2x. I'm going to take the derivative to the -1/3 minus 2, right? That would be my derivative. So set that equal to 0. My suggestion is to factor, well, we can just set it equal. So I'm going to move the 2 over. Oops. Divide by 2, I get x to the -1/3 equals 2. So I'm going to solve it. I'm going to cube both sides. So x to the -1, if I just multiply by 3, 2 cubed would be 8. So I just cube both sides. So x is going to be 1/8, because that's 1 over x. All right, so you can work the algebra there. Now, so I'm going to just test all my values. All right, so I've got x. I'm testing, plugging into f of x. All right, where f of x is this. I'm going to test -1, 1/8, and 8. All right, so I'm just going to use my calculator real quick and plug those values in. 3x to the 2/3 minus 2x plus 1. All right. Hopefully I typed that in right. So, whoops. Gonna let it run the graph here. I'm just using the table now to find the values rather than x equals. So if I do -1, I get 6. If I do 1/8, it's 1.5. And I do 8, I get -3. Okay, so once you have the values, it's real simple, right? Pick the lowest for the minimum. So this is the absolute min right there of -3, and the absolute maximum value is 6. Okay, they happen to both occur at the endpoints there. All right, when you're working with extrema, you need to be aware of the domain. Okay, there's some times where function's undefined. If it has a hole or a vertical asymptote or a jump, in the region of x, you're considering the extreme value theorem no longer holds, because the deal was it had to be continuous. All right, and when the continuousness of it goes out the window, so does it having this. We don't guarantee it has an absolute minimum or maximum unless it's continuous. So just keep that in mind on the interval. It has to be just continuous on the interval. So let's take a second and talk about domain. Domain is the regions of x for which a function is defined. The range is where the function is defined for y. So when I look at a graph like this, the domain, it's all values of x. So this graph goes from -3. The arrow means it goes forever. So I know that x is going forever in that direction, but it stops here at -3. And it doesn't include -3 because it has the open circle. So the domain of that would be -3 to infinity. The range, it goes down as low as 4 and includes 4 because that's part of the graph, or -4. And it's going to go up all the way, so y goes all the way to infinity. Okay. All right, arrows, it's going over and out and down, and it's all reals in both cases. X goes all the way to the left, all the way to the right. So you can write it like this, you can write it as all reals. The range goes all the way down and all the way up. Okay, so the domain of this graph, it appears, I'm going to draw it, it should be probably drawn in. It looks like it has a vertical asymptote at 1, so that's what we're going to call it. So the domain, it goes from 1 to 3. It doesn't include 1 because it never reaches 1, and it stops at 3. The range, it starts at down here, that's -1, and it goes up forever. So that would be from -1 to infinity. All right, so the domain that we care about is with fractions. When you have a fraction, the bottom can't be 0 because you can't divide by 0. So pretty much, if I set the bottom of this to 0, right, I get x is -2. So it tells me that x can't be -2. All right, so a way to think about writing it with intervals, here's my number line, here's -2. So -2 is excluded. So the domain is everything but. So we take one region from -infinity to -2, and then another region from -2 to infinity. All right, so that would be the domain with brackets. All right, so just to kind of review, to find the y-intercepts of a function, you set x to 0. So I get f of x, or y, equals 0 minus 1 over 0 plus 2. Well, that's easy. That works out to be -1/2. So I know what the y-intercept of this is. To find the x-intercept, I set the whole thing equal to 0. I want you to notice something with rational functions. To clear the bottom, I'd have to multiply by x plus 2 on both sides. So those cancel. 0 times anything is 0. So really all you're doing is taking the top of the fraction and setting it to 0 to find the x-intercepts. So once you get that, you just move that 1 over and I get x equals 1. So this is going to cross the x-axis at 1, 0. Okay? All right. So just some more practice. You know, when you're trying to find the domain, you're going to want to factor. I'm going to factor everything out. So factors of -24 that add to -2. That's 4 and 6. So this is going to be x minus 6, x plus 4 on the top. The bottom will factor x minus 4, x plus 4. Now let me tell you a little bit. Where factors cancel, it's a whole. All right. So these two factors cancel, but before I cancel them, I'm going to write my domain down. So what can't x be? So if I look at it, this thing equals 0 at 4 and -4. So x cannot be 4 or -4. That's your domain. All right, now once you've written the domain, you can get rid of stuff. These cancel. So this is really the same thing as x minus 6 over x minus 4, as long as x does not equal -4, which I wrote right here. All right, so I can work with that form now. So to find the y-intercept, I set x to 0. So I'm going to get 0 minus 6 over 0 minus 4, or if I reduce that, it's going to be +3/2. Okay. To find the x-intercepts, I set y to 0, and we talked about this just a second ago. All you have to do is set the top to 0. Ignore the holes because those cancel, right? They're gone. They're not x-intercepts. All right, so I just set the top to 0, and I get x equals 6. Okay. All right, one more example. See if you want to pause the video and see if you can do it on your own. That's fine. I'm going to work through it. So the bottom can't be 0, so I know that x can't be 0. That's my domain. All right. To find the y-intercept, you set x to 0, right? So I'm going to get 0 squared minus 9 over 0. And you go, whoa, that's -9 over 0. You cannot divide by 0. So this means there is no y-intercepts. Okay, this will never cross the y-axis. All right, x-intercepts, remember all you got to deal with is the top. A couple ways to solve this. If I move the 9 over, take the square root, but don't forget the plus or minus. So it's plus 3 or minus 3. So those are your x-intercepts. Okay. I just gave you the domain. The domain of this is x can't be 0. Now, the range is harder. What I like to do is just look at the graph. I'm going to pull it up on my calculator and get the range that way. It's less common for you guys to have to find the range. X squared minus 9 over x. So if I take a look at that graph, I'm going to draw for you what I see, because all I'm doing is going to parrot what I see. It looks something like this. It has a vertical asymptote at 0. But when I look at this, this takes on all values of x. It goes all the way down, y, all the way down and all the way up. So the range would be all reals. Okay. I'm not so worried about range. All right, so we're going to work some algebra with rational functions and find the critical values of it on a closed interval. When I work with a rational function, the first thing I do is take note of the domain. So like the bottom can't be 0. So I know that x minus 4, if that equals 0, then x is 4. So x can't be 4. That's my domain. So I'm going to stay away from that value. Notice that 4 is not on the interval, so that's fine. This is continuous on that interval. So let me find the critical values by taking the derivative. All right, so the derivative of the top, I'm going to do here. The top is 4x minus 8, and the bottom is x minus 4 squared. Derivative of the top then would be 4, and the derivative of the bottom would be 2 times x minus 4. Okay, I'm going to leave it like that. All right, so what we're going to do is use the quotient rule. So it's the derivative of the top, which is 4, times the bottom, minus the derivative of the bottom, times the top, all over the bottom squared. X minus 4 squared is x minus 4 to the 4th. Now I left things factored for a reason. You see that x minus 4 is a common factor. So I can take out one of those, and I want to do that. One of the tips that you're working with, when you're working with quotients like this, don't multiply them out, because you're going to get like cubics and just gross stuff sometimes. It's better to factor stuff out first. So I'm going to factor out an x minus 4. So I can take an x minus 4 out in the top, and then I'm left with 4 times x minus 4 minus 2 times 4x minus 8, right? So you see I just pulled out one factor, and then I'm dividing by x minus 4 to the 4th. So by doing that, right, this cancels with that, and oops, now I got 3 of them. So that's a little easier than working with all the multiplying, but now I got to multiply out the top, so I'm going to distribute through the 4. So I get 4x minus 16 minus 8x minus 2 times minus 8 is plus 16. Don't forget the sign. And then we have over x minus 4 cubed. Okay, so that goes away. So I end up with negative 4x, is that right? Over x minus 4 cubed. The nice thing with rational functions, to figure out the critical values, I set this to 0. And again, where it equals 0 is pretty much where the top is going to be 0. So if negative 4x equals 0, x equals 0 is a critical value, and it's on the interval, so I need to test it. So I'm going to start setting up my chart. Negative 2, 0, 3. Now, 4 is also a critical value because the derivative is undefined there. But it's not really a critical value because we know that x can't be 4. 4 is not in the interval, so we're not interested in 4. So now it's easy. We've got our values to test. We're going to plug them back into the original function, not the derivative. So we're plugging it into here, and we pick the highest and the lowest. So I'm going to plug that in my calculator to save me a little bit of time. Save you time. 4x minus 8 divided by. All right, and then graph that. I'm going to find the values. All right, I'm just using my table to save me a little bit of time to find the values. So f of -2 appears to be negative 0.44, -4/9. We'll just call it that. F of 0 is -1/2. And f of 3 is 4. All right. So which ones? So this is obviously my maximum. And the minimum, which one's less? Let's see, 4/9, 1/2 is 4.5/9. So this one would be less. So this would be my minimum. Okay. So anyway, so that's my answer. That's all I have to do. But be aware with fractions. I want to talk about this. Make sure that with the algebra, you see how I kind of kept things factored here, because that way I could pull out that x plus 4, because if you don't pull it out in the beginning, it's going to be hard. Okay, so tip number 1, when working with expressions that repeat in terms, like what I mean by that, you have x minus 4 in all 3 terms, don't multiply them. All right, factor out the expressions, and your life will be easier. All right, so another type of problem you're going to have to work with is fractional exponents. All right, so the domain of this, there's no negative fraction. If there were a negative exponent, you'd have a what do you call it? You'd have a different domain, and you know, if you could take a square root, but you're doing cube roots, so its domain's all real, so we don't worry about that. I'm going to go ahead and take the derivative to find the extrema that fall within this range. Okay, so if I take the derivative, it's 4/3 x to the 1/3 minus 2x to the -2/3. And I want to figure out where that equals 0. So with fractions, remember, pull out the most negative exponent. So I'm going to pull out x to the -2/3. All right, so when I do that, 1/3 minus a -2/3 is actually 3/3. So it's just 4/3 x. And those cancel, minus 2 equals 0. Okay, so now I have something I can work with. This here, remember, because it's negative, it's on the bottom. So this is undefined at when x is 0. Okay, because that's going to be dividing by 0, because this is really like this over x to the 2/3. That's really what we're talking about. So either x equals 0, that's a critical value, and it's part of the domain because the domain's all real. So just because it's undefined doesn't mean it's not in the domain. So the other one, let's see, if I set 4/3 x minus 2 to 0, multiply by 3, I get, when you work the math, you're going to get 6/4 or 3/2. All right, so both 0 and 3/2 are on my interval, because 3/2 is 1.5. So we're going to make us a table and pick the largest and the smallest. All right, so -1, 0, 3/2, and 3. And I'm just going to set, at this point, I'm going to just type that expression in my calculator, and I'm just going to pull values off of it. You can just plug it in the calculator. X to the 4/3 minus 6x raised to the 1/3 minus 1. All right, so I'm just going to plug some values in my calculator here. Interesting graph. -1. So -1 works out to be 6. Let's see, 0 works out to be, I'm just pulling them off the table right now. It makes out to be -1. 3 is negative 5.327. 3/2 I'll have to do second calc value. X is 1.5. Y is negative 6.151. Okay, so I can see from this that -1, this is my absolute max. And here's my absolute min. Okay. Most of this, the difficulty is working in algebra. So remember, when you have fractions, take that derivative and pull out the most negative exponent. So tips: when factoring common factors with fractions or negative exponents, pull out the most negative power of x you can find, okay, when they all have x in them. The derivative can be undefined in interval and still be in the domain. So that's what we saw here. The derivative was undefined at 0, but the domain is all reals, okay? What that means usually is you have some kind of corner or something. If you graph it on a calculator, you should see a sharp corner at 0. Okay. All right, so make sure that to check for minimums and maximums, you also check where the derivative is 0, but where it's undefined as well. Okay. Tip number 4, watch out for negative exponents. We just talked about they'll have places where they're undefined since they actually create a denominator. So for example, x to the negative 1/2 really means 1 over x to the 1/2 or 1 over the square root of x. So x can't be 0 because you can't divide by 0. But watch for those negative exponents, okay? All right. So what we're going to do now is pretend that we found the derivative, and we're going to practice with some of the algebra because my main concern is the algebra. So we're going to practice finding all critical values, okay? So with this first one, when I look at it, I go, oh, there's fractional exponents. So I'm going to take out the most negative power that I can. So I'm going to take out 5a minus 1 to the negative 1/4. 5a minus 1 to the negative 1/4. All right, so you subtract the exponents. 3/4 minus negative 1/4 would actually be 1. So it's times 2 times 5a minus 1. Excuse me, to the first power. This just cancels out because that's negative 1/4. So plus 7a. So we have something that is much more easy to work with now. This can be simplified, the inside here, into 10a minus 2 plus 7a. So this becomes 17a minus 2 over 5a minus 1 to the 1/4. All right, so critical values are where the top equals 0 and where the bottom equals 0. So the top equals 0, where 17a minus 2 equals 0. If I solve that, I get a equals 2 over 17. The other guy, where 5a minus 1 equals 0, where a equals 1/5. So 2/17 and 1/5 would be the critical values that I need to check. All right, again, more practice with fractional exponents. The lowest power would be x to the negative 1/3 here, and that's all they have in common. So I'm going to take out an x plus 2 to the negative 1/3. And I'm left behind with 3x plus 4. Now this one you're dividing by, keep in mind what you're dividing by that, x plus 2 to the negative 1/3. So 2/3 minus a negative 1/3, well, guess what that is? That's 1. So it's 4 times x plus 2. X plus 2, just to kind of keep that straight, to the negative 1/3. So I did 2/3 minus negative 1/3. So that's going to be 1. That's why it became that. So I can simplify this here. 3x, distribute the 4, plus 4x plus 8. Okay, so, and this is going to equal 7x plus 8. over x plus 2 to the 1/3. Okay, so where the top equals 0, where the bottom equals 0 are my critical values. So if 7x plus 8 equals 0, if you go ahead and solve that, you're going to get -8/7. And if x plus 2 equals 0, you're going to get x equals -2. So those would be the critical values that we would need to check. All right, so here's a complicated looking one. Again, take out the common factors. Like I look at the x plus 1s and I see every term has an x plus 1. So I'll take out an x plus 1 on the top. And I also see that both terms on the top have a factor of x in common, so I'll take that out too. So what am I left behind with? I have a -2 in the first term, and that's it. And the second term, I'm going to have an x. Oh, I'm going to have an x times an x plus 1, x plus 1. Because I took out one of these guys and one of those guys. All right. So that will cancel with one of those, and that becomes a cube. So I have x. If I distribute this through, I get x squared plus x minus 2. Now we have this here. That top will factor. That's going to be x plus 2, x minus 1, I believe. Yep. X plus 1 cubed. So there's a bunch of critical values here. So the top equals 0 at 1, -2, and 0. The bottom equals 0 at -1. So those would all be critical values that would need to be tested for absolute extrema. Okay, we'll do one more of these and then we're going to end this video. So, wow. Okay, so I'm gonna make this look look a little better. I'm gonna make this 2x minus 3. This is actually in factored form for us because, you know, you can factor the bottom here. It's x minus 3 and x plus 3 raised to the 3/4. Remember, the negative brings it downstairs. And this whole thing is, it doesn't really matter what this is. I'm just going to figure out where the top equals 0 and where the bottom equals 0. So the top equals 0 where 2x minus 3 equals 0. So x would be 3/2. That would be a critical value. The bottom equals 0 at -3 and 3. So those again are critical values. So all of this are your critical values. Okay. All right, so that's the end of the first day. What I'm doing here is just trying to show you some of the algebra involved with this stuff. You know, you may have to factor out expressions of x. You may have to factor out negative fractional exponents. So I wanted to kind of show you all the algebra. In the next video, I'll show you how to work with E and also show you some tips for using your calculator. All right, and there's a Pearson assignment associated with this video. So you have, after watching this video, you should have the ability to go ahead and do the Pearson. All right.